Good morning, ladies and gentlemen. Today we're going to talk about something called linear programming. This has a lot to do with the last test that you took, and this is actually something that you did in Algebra 2 last year, so hopefully this is a good review for you. I need for you to recall what is a system of linear equations and linear inequalities. Well, you know that a system means two or more equations or inequalities. For a linear equation, the answer is where the two lines intersect. So for example, if I have a coordinate plane and I have two lines, because these are equations, the answer to this system is where they cross. It's their intersection. Okay, but if I take this and turn it into an inequality, meaning I have greater than symbols or less than symbols, then I could have dotted lines, I could have a solid line, and then we have to do some shading. So maybe this one was shaded above, maybe this one was shaded below, and then the answer is where the shaded part overlaps, which in this case would be over here. Okay, so again, that is all stuff that we talked about last week. Today we're going to talk about linear programming, and linear programming is an application of systems to maximize or minimize a value. Okay, so this is going to be some application. And this is in one or two variables, and we're going to use two variables because we are going to be on a coordinate plane. So first things first, we have this objective function, okay? And the objective function is normally z equals something, okay? The point or the objective is to maximize or minimize something. Okay, and this first section is going to show us how to do that. So take a look at the next section here. It says, find the value of the objective function at each critical point of the graphed region. Determine the maximum and minimum values of the function. So here's my graph in number one. It kind of looks like well, it is a quadrilateral, okay? The critical points, if you see here, the critical points are the corners, and you can see that these have been clearly labeled for you, okay? These are your critical points. So I have 1, 2, I have 8, 3, I have 7, 5, and I have 2, 10. So these are my critical points. I am going to take these x and y values and I'm going to plug them into my objective function, and it's going to give me a value. So here we go. This is my x, this is my y. I have 5 times 1 plus 6 times 2. So notice I just took those numbers and I plugged them in to the x and the y in that objective function. And this gives me a value of 70. Let's do it again. I have 5 times 8 plus 6 times 3, and that gives me a value of 58. Oh, excuse me, this does not give me a value of 70. I don't know what I'm looking at. 5 times 1 and 6 times 2, that gives me a value of 17. Now I have 7 and 5. So 5 times 7 plus 6 times 5, this gives me a value of 65. And last but not least, I have 2 10. So 5 times 2 and 6 times 10, that gives me a value of 70. Okay, so those are the values for each critical point. Now it says I want to know the maximum and the minimum. Well, the maximum is just the highest. So this right here is going to be my max, and this right here is going to be my min. All right, let's try it again. I got another quadrilateral over here, and again, my critical numbers are just the corners of this figure. So I have 0, 0, I have 8, 0, 4, 9, and 0, 8. So we're going to take these and we're going to plug them into your objective function for the x and for the y. So this will be 40 times 0 plus 50 times 0, and that of course is 0. Then I have 40 times 8 plus 50 times 0, and that will give me 320. Then I have 40 times 4 plus 50 times 9. Let's see here. That will give me 610, I believe. And then I have 40 times 0 plus 50 times 8, and that will give me a value of 400. So those are all of my values. Now the minimum is 0, and the max looks like 610. So that's how you use the objective function. Now, the graph was given here to you in these first two problems. If you look at my next 3 examples, you will notice that you have to make your own graph. Okay, so here we go. It says an objective function in a system of linear inequalities representing restraints is given. Graph the system. Find the values of the objective function at each corner. Determine the min and the max values. So first and foremost, this is my objective function. That does not get graphed. That says z equals. Now I need to graph my constraints. Well, if we take a look, I'm going to try and color code these a little bit. I'll call this one the red one. Now notice that says x is less than or equal to 6. Normally when we graph, we want the y's to be by themselves. Well, this one doesn't have a y. So that means we go to where x is 6, 1, 2, 3, 4, 5, 6, which would be right about here. Because there is no y, it can't cross the y, which means this is going to be vertical. Please notice it also has an equals bar. So this thing will be solid and it will be vertical. And there's my first line. Now, it says less than 6, so we need to do some shading on here. If I'm going to shade the things that are less than 6, normally we say above or below, but here we have to go left and right. And this would be the things that are less than 6. And I would highly suggest you shade that very lightly. All right, let's do the next one. I have y is greater than or equal to 1. So again, the y is by itself, so we're going to start at 1. It's a solid line. So it will be, it is a equals bar, so it will be a solid line. Now there's no x, so I can't cross the x, which means this has to go horizontally. So we're going to look something like this. And that says greater than 1, so we need to shade above that line. So we're going to shade above that line. And again, I highly suggest you do this very lightly. And this would go all the way up here. Okay, and the last one, we need to isolate for y. So the first thing I'm going to do is subtract the 2x. Then I'm going to divide by a negative 1. Now notice I said divide by a negative, so I got to flip that symbol over. And it looks something like that. So I'll start at plus 1, which was right here. And I need to go up 2 over 1. Oops. And this line will also be solid because of that equals bar. And it looks like that's a less than symbol, so I need to shade below this thing, which would be down here. Actually, that blue is not really showing up very well, is it? Let's see, let's get a different color here. How about this one? That's a little better. Okay, so now I need the overlap of all of these things, all of the shading. And that would be this triangle in here is where all of those overlap, okay? So now, what are the critical points? What are the corners of those overlapping pieces? Well, that point right there is 0, 1. This point down here is 6, 1. And this point up here is 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 6, 13. So those are the numbers that I'm going to use for my objective function that I am going to plug in. So let's take those x and y's and let's plug them into our objective function. So I have a min of 1 and I have a max of 19. So again, that's just me plugging in the x and the y into that objective function. Okay, let's go to the back. You'll notice I have my objective function with my x and my y right here. I have some constraints. I would like to go down to the bottom two constraints first. Please take a look at these two. Okay, that says x is greater than 0 and y is greater than 0. Well, if x is greater than 0, that's where all the x's are positive. I need you to understand that this coordinate plane would really be like this. Okay, all my positive x's would be over here. Remember, to the right is positive x's. All my positive y's, because that says greater than or equal to y, those would all be up here. Okay, so notice where the double star is. So really, x is greater than 0 and y is greater than 0 is telling me I'm in the first quadrant. Okay, which is why I only have the first quadrant of a graph posted there for you. All right, so I just need to isolate those other two. Let's call this one the red one. I'm going to need to subtract the x, and I get that. So I'm going to start at 12. And I need to go down one, right one. And then this will be a solid line because of that equals bar. Will look something like that. And I want to shade below this thing. So below would be down here. Okay, I'll call this one the blue one. I'm going to have to subtract the x. Then I have to divide by the 2. So I have y is less than or equal to negative 1/2 x plus 10. Start at the 10, which would be right here. And we have to go down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And we can continue all this over till we get to that corner. And this will also be a solid line, which will look something like this. And again, we wanted to shade below this, which would be down here. So it looks like the overlapping part is this shape right here. Okay, so my points, I have 0, 0. Remember, these are just the corners. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0. I have this guy up here was 0, 10. And then let's see, what point do they overlap on? It looks like this one right here. Okay, so that is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So folks, you really need to be careful when you graph these, so you make sure you understand the ordered pair where they do cross. So these are my critical points that I'm going to use in my objective function. Okay, so let's plug them in. I have 6 times 0 plus 10 times 10, and that'll be 100. I have 6 times 4 plus 10 times 8, which will be 104. I have 6 times 0 plus 10 times 0, which is obviously just 0. And I have 6 times 12 plus 10 times 0, and that will be 72. So it looks like 0 is my min, and 104 is my max. Okay, let's try one more. Again, you see my objective functions. You see this right here, which tells me I'm just in the first quadrant. What you see there is just quadrant 1. And now I need to go ahead and isolate my other 2 for y. Let's call this one the green one. I'm going to subtract the x over. I'm going to divide by negative 1, which means I need to flip it, and it will look like that. So I'm going to start my line at negative 1. Uh-oh, well, that's down here, right? That's fine, okay, but I have to go up 1, right 1. So up 1, right 1, now that gets me on my graph. And it will look something like this. Okay, so this line again will be solid. And it looks like I'm supposed to shade above this one. So let me get a green color here. And we want to go above this. Okay, we'll call this one the blue one. I gotta subtract the x, divide by 2, and it looks like that. It looks like I'm going to start this at 2, and I'm going to go down 1 over 1. Well, that was a pretty short line. And it looks like I'm supposed to shade below that one. Well, below that would be down here. So the overlap is this itty bitty guy right in there. Okay, so I have this point, I have this point, I have that point, and that point. So this is what I'm looking at. It's not a triangle because of that piece on the bottom. I have 0, 0, I have 0, 2, I have, what is that, 2, 1, and down here I have 1, 0. Okay, so if I use these points in my objective function, I'm going to be able to find the max and the min. All right, so 3 times 0 plus 2 times 0 is 0. 3 times 0 plus 2 times 2 will be 4. 3 times 1 plus 2 times 0 will be 3. And 3 times 2 plus 2 times 1, that will give me, let's see, 6 and 2 will give me 8. So it looks like 8 is my max and 0 is my min. All right, folks, so that's kind of the beginning of linear programming. Again, you should have done this last year in Algebra 2. You're just trying to find the corners of the overlapping region and then plug them into your objective function. So your homework is going to be page, let's see here, 420, numbers 2 to 8 even. So you will need to go grab some graph paper off the cart. Excuse me. Make sure that your graph paper is right side up. It's so the numbers are pointing the right way. That way you have a graph to use. All right, we will see you. Now remember, you guys are on your bus trip tomorrow, so I'll see Caitlin tomorrow. And then I will see the rest of you on Thursday.